Alright, this video is going to go over the solving quadratic equations test review. So problems 1, 2, 3, and 4, they all say solve the following quadratic equations by graphing. So when we're trying to solve a quadratic equation by graphing, we want to know, when does the left side here equal the right side? And all of these, if you notice, and on 3 and 4 as well, they're equal to 0. So basically, the line y equals 0 is going to be the x-axis. We're looking for where does this graph cross the x-axis. That's what we're looking for. So you'll notice in problems 1 and 2, they are in factored form right now. So let's graph them using our factored form little tricks. So first off, we want to know, okay, when I've got two things here, x minus 4 times x, when will this multiplication problem equal 0? Well, if it equals 0, that means one of these, either x minus 4 or x, has to equal 0. So I'm going to come down here. So I have x minus 4 has to equal 0, or x has to equal 0. And we'll solve both of these, get x by itself. So on this one, we can add 4 to both sides. So x is equal to a positive 4. And on this one, x is already by itself. So these two values right here, if I plug those values in for x, my y value is going to be equal to 0. So for example, this one right here, if I plug in 4 for x, my y value is 0. And on this one, if I plug in 0 for x, my y value is 0. So let's graph those 2 points. So 0, 0 is right there. In fact, let me do this in a different color because it makes it a little bit easier to see. So we got a point right there. 0, 0. And we also got one at 4, 0. 1, 2, 3, 4, 0. All right, and that's where our graph is going to cross the x-axis. Now, that's all we really need to find on this. When it's asking us to solve this, we want to know when it's equal to 0 right there. Those are our solutions. So we have x equals 0 and x equals 4. Those are our solutions to this problem. But let's keep graphing it just to see what it looks like. All right, from there, once we know where our zeros are, we know this is a quadratic equation, which means that the graph is either going to be a parabola, meaning it's like a U shape that points up, or it's going to be a parabola U shape that points down like that. And it's symmetric either way. And so right down the middle, we have what's called a axis of symmetry. So right here, we've got these two zeros. We know they have to be equal distance apart from the axis of symmetry, which means right here in the middle is going to be our axis of symmetry. Okay. Now on that axis of symmetry, we can see in this picture that the vertex lives on that axis of symmetry. So we know that axis of symmetry is 2 in this case. So if I plug 2 into this equation, let's see what we get out, and that will help us figure out our vertex. So if I plug in 2 for x and solve that, so I put these were x's, right? X minus 4 times x. So 2 minus 4 is a negative 2 times 2 is negative 4. So we plug in 2. Here's what we did. We plugged in 2 and we got out negative 4. So 2 comma negative 1, 2, 3, 4. There's our vertex right there. Let's get 2 more points on here. We know what's happening at 2. We know what's happening at 0. We know what's happening at 4. We don't know what's happening at 1 or 3. But we do know, since it's symmetrical, we should get the same answer either way. So let's check. Let's just plug in 1. So this is just to find another point. Let me do it up here. Kind of running out of room down there. So 1 subtract 4 times 1. So 1 minus 4 is negative 3. Negative 3 times 1 is negative 3. So in this case, we plugged in 1 and we got out negative 3. So we plug in 1, 1, 2, and we get out negative 3. And that's enough right there that we can actually draw our graph. We could find out some more points. For example, you could plug in negative 1 and you'd find that it equaled 5. Same thing with 5. You'd end up getting 5 out. You don't need to find those 2. We found 5 points. That's enough. But that gives us enough to kind of sketch our little graph right here. And as you can see, where this crosses the x-axis at is at 0 and 4, which is actually like the first thing that we found. So if it's already in factored form, these are really easy to solve. And you still have some work if you want to graph the whole thing. But solving-wise, it's actually really easy. All right, let's take a look at problem number 2. So, likewise, on problem number 2, it's in factored form. So we want to set each of these factors equal to 0 and solve. So we've got 2x subtract 1. When does that equal 0? And we've got 2x plus 1. When does that equal 0? So if I add 1 to both sides, we get 2x is equal to a positive 1 divided by 2. So we get x is equal to 1 divided by 2, which is a half. Over on this side, we can subtract 1 from both sides. So we get 2x is equal to 0 subtract 1, which is negative 1. And then we can divide by 2 and get x equals a negative 1/2. And as we learned over here, those are our solutions. That is when this is equal to 0. So let's see. So this is, if I plug in 1/2, we get out 0. And if I plug in negative 1/2, we get out 0. So we got 1/2 comma 0, which is about right there. And we got negative 1/2 comma 0, which is right there, giving us our solutions of x equals negative 1/2 and x equals positive 1/2. But let's just finish graphing this just for fun. So here we go. So we want to figure out these are going to be equidistant from the axis of symmetry. So our axis of symmetry in this case is going to be the y-axis. That's kind of nice. Which means that my vertex lives on that line. So if I plug in an x value of 0, it's going to tell me where my vertex is. So we're going to plug 0 into this. So we've got 2 times 0 minus 1 times 2 times 0 plus 1. So 2 times 0 is 0, minus 1 is a negative 1, and 0 plus 1 is 1. So we get out negative 1. So we plugged in 0, and we got out negative 1. And that's going to be our vertex. Next, let's get a couple more points here. We know what's happening at 0. We also know what's happening at 1/2 or negative 1/2. So let's figure out what's happening at 1 or negative 1. It should be the same answer because they're equidistant from the axis of symmetry. So let's plug in positive 1. Let's do it up here. So I've got 2 times a positive 1 minus 1 times 2 times a positive 1 plus 1. So 2 times 1 is 2. 2 minus 1 is 1. 2 times 1 is 2. Plus 1 is 3. So 1 times 3 is 3. So we plugged in 1 and we got out 3. So we plug in 1, 1, 2, and we get out 3. And this is going to be symmetrical, so we know that's going to be a point as well. And there is our parabola right there. You can kind of see that going right there. And with our solutions of x equals negative 1/2 and x equals positive 1/2. All right, let's take a look at problem number 3. Once again, we are solving, as we can see through this, problems 1 through 4, solving the following quadratic equations by graphing. So these two are in factored form, and we graphed those. But if you look at 3 and 4, these two are going to be in what's called standard form. So we're going to graph these in standard form. All right, so the first thing we want to talk about is what is standard form of a quadratic. And if you recall, I'm going to write it up here. So standard form is when our equation is written in the following format: ax squared plus bx plus c. So, and they don't have to be x's. They could be any letter you want. And in both these cases, they are x's, but they could be k's, they could be l's. You know, it doesn't really matter. But it's your variable squared with your a as your coefficient. That's the number in front of your variable squared term. And then this is your variable just in front of your what's called the linear term, because it's a power of 1. Okay, so this is your linear term, and then your constant term, your number right here. Okay, so if we look over here at question 3, you can see that they are in this order, descending order of power of 2, power of 1, and no x value at all, so power of 0. Power of 2, power of 1, no x value. So these are in, this is already in standard form. So let's make a note of what a, b, and c are. So in this case, we have a is equal to this negative right here, so negative x squared. So that negative is a negative 1. Negative 1 times x squared is negative x squared. So a is negative 1. B, positive 2x, so b is going to be a positive 2. And c is going to be equal to a positive 3. Okay, so those are our a, b, and c values. Now, on our factored form, it was really easy to find the solutions really fast. On the standard form, it's a little bit more complicated. In fact, finding the solution is going to be one of the last things that we do. The easiest thing, probably the easiest thing to find in standard form is where our graph is going to cross the y-axis at. So if we think about that for just a second, if any point on this line right here, that means that it has an x value of 0. So we can actually plug 0 in for x in this equation and see what we get out. So if I have, I'm going to do it up here, negative 0 squared plus 2 times 0 plus 3, well, this part goes to 0, that part goes to 0, and I'm left with 3. So I plugged in 0 and I got out 3. So I plug in 0, I get out 3. That is where our graph is going to cross the y-axis at. And the reason why I say it's super easy is because the quadratic term and the linear term, regardless of what they are, if you plug zeros into those are always going to go to 0, meaning that the c value, right here, our c value is our y-intercept, always. So just really quickly, looking over here at number 4, negative 4.5 is where this thing is going to cross the y-axis at, is at negative 4.5. All right, so now I know it's symmetrical, so I know there's going to be another dot possibly up here someplace, unless this happens to be the max or the min, but I don't know which side it's at. I don't even know where the axis of symmetry is. So that's what we're going to find next. We're going to find the axis of symmetry. Now there's a little formula that you want to remember to find the axis of symmetry. And so axis of symmetry is a handy-dandy little formula when it's written in standard form. It's negative b divided by 2 times a. And that will find the x value of our axis of symmetry. So let's give it a try. So our b value in this case is 2. So I'm going to write it down here, negative, and I'm going to put, notice, in fact, I'm going to just write the blueprint out. So 2 times a. So notice I put parentheses where the b is going to go, and I put parentheses where the a is going to go. And I put the negative here and the 2 there. So we've got b, which is a 2, and I've got a, which is a negative 1. And then we'll simplify that. So on the top, we've got negative 2. And on the bottom, we've got negative 2, which comes up with a value of positive 1. That is our axis of symmetry. So we have an axis of symmetry at positive 1. And that's really nice because now we can see where that's symmetrical at, and we found earlier this point, which means that this is also going to be a point on our graph. Now we want to figure out where the vertex is going to be located. So we know the vertex lives on this axis of symmetry. So we know the vertex has an x value of 1. So let's plug 1 into this equation and see what we get out. So I've got negative 1 squared plus, whoops, that was supposed to be a 2. A little carried away. 2 times 1 plus 3. Okay, got to be careful right here. We have to do parentheses first. There's nothing inside the parentheses. The negative on the outside counts as a multiplication in, and this is an exponent. So we want to do the exponent first. So 1 squared is positive 1 times the negative is negative 1. So negative 1 plus 2 plus 3. So 2 plus 3 is 5. Subtract 1, or negative 1 plus 2 is 1, plus 3 is 4. However you want to do that. So that's equal to 4. So in this case, we plugged in 1, and we got out 4. So I plug in 1 and we get out 1, 2, 3, and 4. There is our vertex. So now let's keep going until we can kind of see what our solutions are going to be. So we know what's happening at 1. We know what's happening at 0 and 2. Let's see what's happening at negative 1 and positive 3. Since it's symmetrical, it doesn't matter which one we check. They'll be the same answer either way. So let's try negative 1. Let's do negative 1. That sounds like fun. So we've got negative 1 squared plus 2 times the negative 1 plus 3. So negative 1 squared is positive 1. Got to do the exponent first. Times the negative is negative 1. 2 times the negative 1 is negative 2 plus 3. Oh, look at that. Negative 1 minus 2 is negative 3 plus 3 is 0. So let's see what we did. We plugged in negative 1 and we got out 0. So I plug in negative 1, there is a 0 right there. So because it's symmetrical, we also know that that is going to be a solution. So where does our graph cross the x-axis at? It crosses at x equals negative 1, and it also crosses at x equals positive 3. And with 5 dots, that's enough to graph this thing. You could also check, if you plugged in negative 2, you'd end up getting negative 5. Same thing with a 4. You don't need to do that though, but that gives you 7 points. We've already got 5. Wow, that was not a very good parabola. I don't know what's going on in here. So, all right, cool. So there's the answer to problem number 3. All right, problem number 4 looks scary, but it's not too bad. It's got decimals, and that's okay. So the first thing we want to do is recognize that it is in standard form. So let's figure out what our A, B, and C values are. First, let's check to make sure they are in the correct order. So I've got my quadratic term listed first, my linear term listed second, and my constant term listed third. So this is in standard form. So our A value is going to be positive 1.5. Our B value is going to be positive 3, and our C value is going to be negative 4.5. All right, so we can quickly find the y-intercept. It's just when it's written in standard form, our y-intercept is our C value. So 1, 2, 3, 4.5. We know that's where our graph is going to cross the y-axis at. Next, let's figure out what our axis of symmetry is. If you recall from question number 3, the way to figure out the axis of symmetry is by using this formula right here, negative b over 2a. So I'm going to do the same thing on this one. Negative, we'll put our b value right there, divided by 2 times our a value. Our b value in this case is positive 3. Our a value is 1.5. So let's simplify that up a little bit. So we have negative 3 on top. 2 times 1.5 is 3. And negative 3 divided by 3 is negative 1. So we know our axis of symmetry is right here at negative 1. Cool. Now we know another dot. We know because it's symmetrical, so we know that's got to be a point right there. Next, we want to figure out where our vertex is located. So let's plug in negative 1. So we're plugging into this equation right here. So we've got 1.5 times negative 1 squared plus 3 times a negative 1 minus 4.5. We want to simplify that. So over here we have to do the exponents first. This is a multiplication problem right here, and exponents come before multiplication. So negative 1 squared is positive 1 times 1.5 is 1.5. 3 times a negative 1 is negative 3 minus 4.5. So 1.5 subtract 3 is negative 1.5, and negative 1.5 minus 4.5 is negative 6. So look what we did. We plugged in negative 1 and we got out negative 6. So plugged in negative 1 and got out 1, 2, 3, 4, 5, negative 6. So there is our vertex right there. Next, let's kind of branch out a little bit and see what this graph's going to look like. So we know what's happening at negative 1. We know what's happening at 0. We know what's happening at negative 2. Let's figure out what's happening at negative 3 and at positive 1. They're going to be the same answer because it's symmetrical. So let's try positive 1. Let's see where we got some room. Let's do some room right here. So we got 1.5, plug in a positive 1 squared, plus 3 times a positive 1 minus 4.5, kind of running out of room there. We got it. All right, 1 squared is 1 times 1.5 is 1.5 plus 3 minus 4.5. So 1.5 plus 3 is 4.5, and 4.5 subtract 4.5 is 0. So in this case, we plugged in 1 and we got out 0. So we plug in 1, we got out 0, which means symmetrically we're plugging in negative 3 and also getting out 0. So our solutions are those 2 points right there. X equals, here it's 1, 2, x equals negative 3, and x equals 1. Those are our two solutions. And let's just graph this thing right here. So see our nice little parabola curve right there. And we're done with that problem. All right, problem number 5. It's a little matching. We've got match each discriminant on the left with the number of solutions its quadratic equation would have. So let's talk about what a discriminant is. To know that, you've got to know the quadratic formula. So I'm going to come over here and write out the quadratic formula. So we've got the quadratic formula is negative b plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And the discriminant is this piece right here, the b squared minus 4ac. And so you can kind of see that right here. This would be a b squared minus 4 times our a value times our c value. b squared minus 4 times our a value times our c value. B squared minus 4 times our a value times our c value. And what this tells us, it's called a discriminant because it discriminates. It discriminates on how many solutions or what kind of solutions we are going to have. And here's how it works. If this value right here ends up being 0, then the plus or minus here doesn't do anything because I would be taking negative b plus 0 and negative b minus 0, which gives me the same answer. It just gives me negative b. Adding or minusing 0 doesn't do anything. So if my discriminant equals 0, there's going to be a single one solution, one real solution. Okay? Now, if this ends up being a positive number, okay, let's say it ends up being positive 4, for example, then I would take the square root of that, get square root of 4, which is 2, and I'd be taking whatever my b value is. I'd be adding 2 for one answer, and I'd be subtracting 2 for another answer, and that's going to make a difference. So if the discriminant is positive, then we end up, sorry, I should put real right there. We end up with 2 real solutions. And you might be wondering, why are we putting real? What does that mean? I'll explain in the next one. So now we've discussed if this is equal to 0. We've discussed if it's positive. So what happens if it's negative? Let's say it was a negative 4. Then we have the square root of a negative 4. And what is the square root of negative 4? Well, it can't be 2. Because remember, it has to be the same number times itself. And 2 times 2 is equal to a positive 4. So it's not 2. Okay, well, let's try negative 2. Okay, so it's got to be negative 2, right? Negative 2 times negative 2, but that's also equal to a positive 4. Well, then what about negative 2 times positive 2? That's equal to a negative 4, but the problem here is those are not the same numbers, so that can't be it. This is called a complex number, also known as an imaginary number. And it's not what's called a real number. And a real, that just means it's the way that they define this group. I mean, these still exist. They still have very much use in real world stuff. If you go into electrical stuff like electrical engineering, these complex numbers are used. But the important part is if that discriminant is negative, you end up with 2 non-real solutions. Or in this case, the way we've got it phrased here is 0 real solutions. So if there's 2 non-real solutions, that must mean there's 0 real solutions. Because at most, with a quadratic equation, this is probably more information you want. So here's a standard form of a quadratic. The highest degree is going to tell you what are the total number of solutions you can possibly have. So in this case, a quadratic will only ever have 2 solutions at most. So if I'm saying that 2 of them are non-real solutions, that means there can't be any real solutions. So if the discriminant is negative, okay, it comes out to be a negative, then we have 0 real solutions. And that's all there is to it right there. So let's come over here now. Let's take a look at the first one. We have negative 4 squared. So I'm going to put equals right here. Negative 4 squared. That's negative 4 times the negative 4 is positive 16. Negative 4 times 4 is negative 16. Times 1 is still negative 16. So we have negative 16 minus 16, which is 0. So this discriminant came out to be 0, which means my original equation from what I was trying to solve, the discriminant was 0. My original equation will have 1 real solution. So this is A. A has one real solution is A. All right. B, 5 squared is equal to 25. Negative 4 times 1. Negative 4 times 1 is negative 4. Times 6 is negative 24. So we have 25 minus 24 is a positive 1. Okay, so our discriminant came up with a positive number, so it's going to have 2 real solutions. And lastly, C, we have 2 squared is 4. Negative 4 times a negative 3 is a positive 12. Times a negative 2 is negative 24. 4 minus 24 is a negative 20. It's a negative number. That's the key part. It's negative. So my discriminant is negative, so there are 0 real solutions. They're both imaginary or both complex solutions, which means that C has 0 real solutions. And that's problem 5. All right, let's take a look at questions 6 through 9. It says directions for problems 6 through 9. Solve the following quadratic equations by factoring. All right, work must be shown for full credit. So here we go. We get to factor these ones. Oh, look, problem number 6 is already factored for us. So if we recall from problems 1 and 2, when we're solving by factoring, we just want to know, hey, when does this equal 0? So we have something times something is equal to 0. Well, in order for something times something to equal 0, one of them has to be equal to 0. It's the only way you can multiply two things together and get 0. So we're going to check both of them. We're going to say, okay, what if it's x plus 7 that's equal to 0? And we'll also check, what if it's x minus 5 that's equal to 0? So let's solve this guy. We're going to subtract 7 from both sides. We're going to get x is equal to a negative 7. There's one of our solutions. And on this side, we're going to add 5 first. So 6x is equal to a positive 5. 0 plus 5 is 5. And this is 6 times x, so we're going to divide by 6. We get x is equal to 5 divided by 6. And there are two solutions. X equals negative 7, and x equals positive 5 over 6. All right, problem number 7. That was the easy one. Now we get to do the harder ones. All right, problem number 7. Notice this one is not written in factored form, so we're going to have to factor it first. So if you remember, the first things we want to check when we factor is there a common or a greatest common factor between all of the terms? In this case, these first two terms are both divisible by x, but this one's not, so we can't factor out an x. And our x squared, it has a coefficient of 1, so we can't pull anything out bigger than 1. So the only thing we could pull out would be a positive 1, but it's not going to change anything. So there is no greatest common factor here. Step 2 is we're going to take our a value. Remember, this is written if it's written in standard form, we have ax squared plus bx plus c. We're going to take our a value, which is 1, and multiply it to our c value, which is negative 15. So we got negative 15. Now what we're going to do is we're going to turn this 3-term problem into 4 terms. So we want to figure out two numbers that multiply together to get negative 15 and add together to get 2. And we've got negative 3 and positive 5. We'll do that just nicely. Negative 3 times positive 5 is negative 15. If I take negative 3 and I add 5 to it, I get positive 2. Now, it might take you a few minutes to figure that out, and that's fine. I would just go through and make a list of everything you can think of that multiplies to 15. But for the sake of time, this is how we're doing it. So what we're going to do is we're going to replace that 2x with negative 3x plus 5x, because that's still equal to 2x. So I'm going to replace that middle term with those. So I still have the x squared, but now I'm getting rid of the 2x and replacing it with those, negative 3x plus 5x, and I've still got that negative 15. Now we're going to do what's called grouping, and so I'm going to look for the greatest common factor, but instead of looking at all 4 of them, I only want to look at the first 2. So I want to take a look at these first 2 and what is the greatest thing that they have in common. Well, the coefficient here is 1, so the biggest number I could pull out would be a 1, but they are both divisible by 2, so I can divide out an x, and that's what I'm going to do. So I'm going to divide an x out of these, and it's going to leave me with something in parentheses. So x squared, when I divide it by x, I'm left with just an x. And you can double check that. If I times x by x, I get x squared. Negative 3x, if I divide an x out, I'm left with negative 3. And once again, I can double check that. If I multiply x and negative 3 together, I get negative 3x. So that's the first group. Now I want to take a look at the second group right here. This term is positive, and my first term of my other group was positive, so we want to definitely pull out a positive number. Okay. Question is, what number are we going to pull out? 5x and negative 15, they are not divisible by x. Well, this one is, that one's not, so they're not both divisible by x. But they are both divisible by 5. So I'm going to pull out a 5. That leaves me right here with just an x. And negative 15 divided by 5 is negative 3. And if I did this right, the item inside the parentheses should be identical to each other, which they are. So now the last thing I want to do is I want to factor out. I look at this term and that term and say, hey, what do they both have in common? They both have this x minus 3 in common. So when I pull that x minus 3 out, in fact, I'll just kind of erase it so it's kind of gone. When I factor that out, what am I left with? I'm left with an x plus 5. And now it's in factored form, where we started out with number 6. So what I want to know now is, what makes this value equal? What can I plug in for x to make this factor equal to 0? what can I plug in for x to make this factor equal to 0? So I have x minus 3, when does it equal 0? And x plus 5, when does it equal 0? So I'm going to add 3 to both sides. So we've got x equals 3, and I want to subtract 5 from both sides, so x equals a negative 5. And those are our two solutions. All right, question number 8. Let's come down just a little bit. All right, so the first thing I want to check is there a common factor out of all three of these? I hope so. Those are big numbers. Let's see, 14. 2 will go into 14, and so will 7. I know 2 will go into 64, and it will go into 30, but I know 7 doesn't go into 30. So even if it went into 64, which it doesn't, I wouldn't care about it. So I can pull out a 2. Can't pull out an x because the 30 doesn't have an x on it, but I can pull out a 2. So I'm going to factor out a 2. That leaves me with 7x squared minus 32x minus 15. So I just divided each of those by 2 and put it on the outside. Now the inside here is what we want to factor. So we want to take a look at our a value, 7 times negative 15. That is negative 105. And we are looking for two things that multiply together to get 105 and add together to get 32. And if you make your list, you'll find that 3 and 35 will work just nicely. I need it to be a positive 3 and a negative 35. Those still multiply together to get negative 105. And if I combine them together, I get negative 32. So I've got positive 3x and negative 35x. If you're having trouble with this, there's some other videos you can watch on how to do all this factoring stuff. So I'm kind of going through the factoring kind of quick. But now we're going to replace the negative 32x with those two right there. So I have 2 times the 7x squared. I'm leaving that there, same with the 2. But the negative 32x I'm replacing with positive 3x and negative 35x. And then I've got my negative 15 still there. Now we'll do our group. I want to keep that 2, just keep carrying them along, so we'll just keep that 2 right there. But now I want to group the first two right here, 7x squared and 3x. The largest number that goes into both of those is a 1, so that's not going to be helpful, but they are both divisible by x, so I'm going to factor out an x, and that leaves me with 7x plus 3. This next group, you'll notice that my first term is negative, and my first term of my other group was positive, so I do want to pull out a negative number. 35 and 15 are both divisible by 5, so I can pull out a 5. Leaving me with positive 7x. I'm pulling out a negative 5. So negative 35 divided by negative 5 is positive 7. Negative 15 divided by 5 is positive 3. And you'll notice that our two sets of parentheses there are identical. So what we can do is we can factor out the 7x plus 3, and it leaves us with x subtract 5. Now this time you see we have 3 factors, 1, 2, 3. So if I know all 3 of these have to multiply together to equal 0, one of them has to be equal to 0. So let's check all 3 of them. So I've got 2. 2 is equal to 0. I've got 7x plus 3 is equal to 0. And I've got, kind of running out of room, so I'll put it right here, x minus 5 is equal to 0. Let's start with this one, that last one I wrote down. X minus 5. So let's add 5 to both sides, and we get x is equal to 5. This one right here, let's subtract 3 from both sides. So we get 7x equal to a negative 3. And divided by 7, we get x is equal to a negative 3 sevenths. Now this last one right here, 2 is equal to 0. There's no x value. This is not a true statement, which means there's no way that I can make this factor go to 0. So this one is just crummy. We don't even need that one. It doesn't have an x value in it. There's no way I can change that 2 into a 0 without an x value. So we've got x is equal to negative 3 sevenths as a solution, and we have x is equal to 5 as a solution to that problem. All right, problem number 9. Let's take a look at it. First thing that jumps out at me, you will notice that this is not currently in standard form. We need to make sure it is in standard form. So this is my quadratic term right here. So he needs to be listed first. So we actually have 14x squared, then my linear term, positive 9x, and then my constant term, negative 8. That's kind of tricky, so be very careful about that. All right, now let's take a look at factoring it. There is not a number that divides evenly into all of those, and I can't factor out an x because they don't all have x's on them. So we're going to take our a value, which is 14, and our c value, which is negative 8, and multiply them together, and we get negative 112. And then we're trying to find two numbers that multiply together to get 112 and add together to get 9. And 7 and 16 will do the trick. I need to get positive 9, so I need it to be a positive 16 subtract 7. So negative 7 times positive 16 is still equal to a negative 112. And if I combine those together, I get 9. So we've got 14x squared. Replace the 9x with negative 7x and positive 16x, and we still have the negative 8 left over. So now we group. Take a look at the first group. What do they both have in common? They're both divisible by 7, and they're both divisible by x. So I can factor out a 7x, leaving me with, I guess we'll keep it green, leaving me with 2x minus 1. And on this next set, I've got a positive 16 and negative 8. They are both divisible by positive 8. That leaves me with 2x minus 1. Parentheses are the same, so we did that all right. So our last step, we're going to factor out the 2x minus 1, and it leaves us with 7x plus 8. Those are our two factors, so those two have to multiply together to equal 0. So let's see what happens. 2x minus 1 has to equal 0, or 7x plus 8 has to equal 0. So let's solve this one. We'll add 1 to both sides. So we get 2x is equal to positive 1. Divide by 2, and we get x is equal to 1/2. On this one, we get 7x is equal to a negative 8. And then we'll divide by 7, and we'll get x is equal to a negative 8 over 7. And those are our solutions to that problem. X equals 1/2, and x equals negative 8/7. All right, moving on to question number 10. It says directions. Solve the following quadratic equations by using the quadratic formula shown below. All right, so here's our quadratic formula. It's given to us. That's really nice. So this is what we used to find, instead of factoring, which we could still try doing if they were factorable, we can use this all the time, every single time. We could use this on these other problems as well that we've done before. But specifically, we want to do it with these ones. So the first thing we have to do is we have to identify what A, B, and C are. So this is in standard form. Remember, standard form is ax squared plus bx plus c. That's our standard form. So in this problem, problem number 10 right here, we can see that our a value is the coefficient of our quadratic term, which in this case is a positive 1. So a is equal to 1. B is the coefficient of our linear term, which is going to be a negative 1. And c is our constant term, the one without the variable, so negative 25. And now we'll just plug those three numbers into this equation and simplify. So we've got negative b plus minus the square root of b squared minus 4 times our a value times our c value all over 2 times a. So, whoops, I meant to put that a in, change that a into parentheses instead. All right, so let's see. Our a value, so let's say a right here is equal to 1. So an a value, negative b plus or minus b squared minus 4 times a. So this is an a, and this is an a. Our b value is negative 1. So b goes right here, and b goes right here. And our c value is negative 25. So negative 25 goes right there. And I would just simplify it. Do it one step at a time. So I would say every single time do this, do the discriminant, and then do this kind of all separately from each other, one step at a time. So negative times a negative, that's going to be positive 1. Done with that part. Then we have the plus or minus, and then we have the square root sign. Now let's figure out what's going on inside the square root. We want to probably break this down too. So negative 1 squared is a positive 1. Negative 4 times 1 is negative 4. Negative 4 times negative 25 is a positive 100. So plus 100. And divide that. 2 times 1 is 2. Okay, so kind of did a little bit at a time. Now let's simplify the inside of that radical. So we've got 1 plus or minus the square root of 101 divided by 2. Now, that is our answer right there. That's actually two answers. There is 1 plus the square root of 101 divided by 2, and there's 1 minus the square root of 101 divided by 2. If you wanted to actually calculate this in the calculator, that would be just fine. You just simply type it in, making sure that, make sure you put, when you type it in, make sure you put this in parentheses, the top part, because that has to you have to add those together before you divide by 2. Same thing over here. Make sure you put those in parentheses, or just do it separately and get that answer and then divide by 2. But if you do this one right here, you're going to end up with 5.52, and then we'll round that third digit. I mean, it goes on forever, but 5.525, and this one is negative 4.525. So you can write your answer in actually any of these three ways right here. All of those would be a legit answer. I'm going to circle the decimals, though, because I think that's what we're going to have you guys do, is go down to the decimal form right there. 5.525 and negative 4.525. All right, let's come look over here at number 11. First thing I notice about number 11, you've got to be very careful. It is not written in standard form. If you look, here's our quadratic term. It's in the middle, and it should be in the front. So I'm going to rewrite this. So we've got positive 2x squared. There's our first term. Then our linear term comes next. So negative 2x and then minus 6. All right, so our a value is 2. Our b value is negative 2. And our c value is negative 6. So when we do our quadratic formula, we have negative b plus minus the square root of b squared minus 4 times a times c all over 2 times our a value. So we've got an a value here, we've got an a value there, we've got b values here, and we've got b values there, and we've got our c value right here. Okay, so let's simplify this one step at a time. So I've got a negative 2 makes it positive 2, plus minus the square root of, let's do this in 2 steps. Negative 2 squared is positive 4. Negative 4 times 2 is negative 8. Negative 8 times negative 6 is positive 48. And then the bottom, 2 times 2 is 4. So this right here is going to be 2 plus minus the square root of 52 divided by 4. And that would be our two solutions. You could write them like that, or you could write them as 2 plus the square root of 52 divided by 4, or 2 minus the square root of 52 divided by 4, so you could write it like that. Or you could type them into your calculator and get 2.303, going out 3 decimal places, or negative 1.303, going out 2 decimal places. So either one of those would work. You could write it like this. You could separate them out like that to show both answers. I mean, this is also 2 answers. Mathematicians are just lazy sometimes. So everything's the same except for the plus and minus sign, so we kind of combine that together. Or you can write it in decimal form like that. All right, let's come down here and work on number 12. It is in standard form. Our a value is equal to 2. We do not have a b value. There is no linear term here. That means our b value, if there is no b value, the numerical way of saying none is 0. So b is equal to 0. And then our c value is negative 11. So then we get our quadratic formula, negative b plus or minus the square root of b squared minus, 4, times our a value times our c value, all divided by 2 times our a value. So let's fill in the blanks. So b's are 0s, a's are 2s, and c's are negative 11s. Okay, let's simplify that one piece at a time. Negative 0 is just 0. Okay, so we have 0 plus minus the square root of 0 squared is 0. Negative 4 times 2 is negative 8. Negative 8 times a negative 11 is positive 88. and then 2 times 2 is 4. So if we simplify that, we get 0 plus minus the square root of 88 over 4. Whoops, that's supposed to be 88 over 4. Which you could write as that, or you could write as the square root of 88 divided by 4, and negative square root of 88 divided by 4. Or you could type into your calculator. Let's see, type in our calculator, we get positive 2.345 and negative 2.345. All right, problem number 13. We've got x squared minus x plus 2. So our a value in this case is 1. It is in standard form. That was the first thing you want to check. B is equal to negative 1, and c is equal to positive 2. Then we've got our quadratic formula, negative b plus minus the square root of b squared minus 4 times our a value times our c value, all divided by 2 times our a value. Our b's are negative 1s, our a's are positive 1s, and our c is a 2. So here we go, simplifying it piece by piece. So negative 1 makes a positive 1, plus minus the square root of negative 1 squared is positive 1. Negative 4 times 1 is negative 4 times 2 is negative 8. Divided by 2 times 1 is 2. That simplifies to be 2 plus or minus the square root of negative 7 divided by 2. So you can write your answer like that, or you can write it as 2 plus the square root of negative 7 over 2 and 2 minus the square root of negative 7 over 2. And that's as far as we can go. If you try typing that into your calculator, you'd get an error because this is going to be a complex number or an imaginary number. Because, yeah, it just will. So just know that that's the case right there. So basically what it means is that this does not cross the x-axis is what happens. So our graph of this thing, I don't know what it looks like, but let's say that's our x and y axis. Our graph is going to look something like this, where we have no solutions. It never crosses the x-axis. If you recall from way back up here, when we were looking at our solutions, that's when it crossed the x-axis. So if it has imaginary solutions, it doesn't cross the x-axis. That's important for the test. And that finishes up our test review.